Hey everyone, in this video I'll be talking about constraints and identity columns in SQL and how to load data into a table using constraints and identity columns. I'll be providing all the SQL queries that I am using in this particular video in the video description. You can grab them and you can run them parallelly along with me while watching this video so that it will be a very good practice for you as well. So what are constraints? In SQL, constraints are rules we set on tables to keep your data correct. Constraints help you stop bad data from entering your tables, and this keeps the data consistent. As we discuss further, you will get some good understanding of how constraints help us achieve all of this. As I said, constraints are the rules. There are different types of rules that will be applied on columns in tables. And now let us look at what they are. The most basic and the most important one is the primary key constraint. So basically a primary key constraint is a column or a set of columns that help us uniquely identify each row in a table, and it ensures that every row is distinguishable and serves as the basic constraint for relationship between tables. Let us consider this table products. I'll be recreating this table products. So let me drop the products table and recreate it. Currently, I am not applying any constraint on this table. So the table is successfully created. So without any constraint, I am running an insert statement. So in this insert statement, the product ID is 1. So if we run this insert statement now, the statement executed successfully. And now what I want to do is I would like to add few more records into this table. So let me insert the other record. And for the other record, the product name is MacBook Pro. In the previous case, the product name is iPhone 5. But the product ID is 1 in both of the scenarios. So let me see what happens if this is executed. So I have executed second insert statement as well with the product ID 1. And let me try one more insert with the same product ID for a different product. So this is also successfully executed. Now if I look at this products table, so it has product ID 1 for 3 different products, and the product names are different and rest everything is different. But the problem is how do we identify the row 1 uniquely compared to the other rows? So that's by having some ID or some column which can be used to uniquely identify this particular row. So now everything is having a product ID 1, and if you use a query something like this where product ID equal to 1. If you run this query, you will get 3 records. But what we want is we wanted to have only one record which will be uniquely identified based on this product ID. So in that case, we need to create a constraint on the product ID column. So that constraint is the primary key constraint. And creating a primary key constraint is very simple. In your create table statement, after the data type, you just need to provide primary key keyword. And if you create a table with this keyword, this column product ID will become the primary key of this table. And let me try to recreate this table. I'll drop and I'll create it again. So once I created this table with primary key on the product ID column, let's see what happens if I try to insert this record 1. So it has inserted, and let me try to insert another record with the same product ID on the primary key column. So it says that duplicate key value violates unique constraint on product's primary key. So the product ID equal to 1 already exists. The primary key constraint will basically apply two rules on this column product ID. Rule 1 is the uniqueness rule. Uniqueness meaning this column product ID, which is a primary key, should not have any repeating values. If we have product ID as 1 for one row, no other row should be having this product ID as 1 again. So it should be distinct for all the rows. And there is one more rule. So if you try to insert any null value for this column, it will fail because the product ID column is a unique identifier. It should not be null. So now to solve this, what we do, we change this product ID to 2 here and we change the product ID to 3 here. Now when we try to insert this record with product ID 2, it will successfully run. And if we also try to insert some other record with product ID 3, the insertion is successful. Now when you run this query, like select star from products where products ID equal to 1, you will exactly fetch only one record. Product ID is going to be unique identifier for each row in this table. When you say product ID equal to 2, it will get you some different record. So it will be product ID 2 MacBook Pro and some other data, and for product ID equal to 3, it will be some other data. So with this condition, there cannot be multiple rows in the same table, and this is how primary key helps us uniquely identify each row in a table. And now primary key can also be created like this. In the previous case, we have just mentioned this primary key in the column definition. Instead of this, if you want to provide a name of your choice to the primary key, you can do it like this as well. So you can have your table DDL, and at the end of everything, after all the columns, you can mention the constraint, and you can provide the name of the constraint as products pk, and you will tell this is a primary key constraint on the product ID column. So this will achieve the same result as the previous DDL, which is this create table command, except the fact that the primary key will be named as products pk. So naming the primary keys is a good practice for better database management. So this is how the primary keys are defined and used in tables. But sometimes a single column is not enough to uniquely identify a row. So in such cases, you can create a composite primary key which consists of multiple columns. So the DDL is very similar to what we have earlier, but in the constraint column inside the primary key keyword, I am passing two columns, which is product ID and product name. So these two columns combinedly will form a primary key on this table. So I'm dropping this table products and I'm creating this table products again. Now if I try to insert this data, let's say I have the same data. If I try to insert data with product ID 1 in all the cases, see, I am inserting the data as product ID 1 and the product name is iPhone 15, and product ID 1 and the product name is MacBook Pro, and product ID 1, the product name is AirPods. But the primary key is on two columns, product ID and product name. So 1 and iPhone 15, these two records shouldn't be repeating in any of the rows. So let's see how this works. So I'll try to insert one record. So I'm inserting a record with product ID 1, and then again I'm trying to insert a record with product ID 1. The insertion is successful even with the primary key constraint because the primary key is on combination of two columns, product ID and product name. And if I insert the third record, it will run fine. Now if I query the table, if I query the table with product ID equal to 1, it will provide all the columns. But if I query the table with product ID and product name both, and I will say the other column is going to be iPhone 15. If I query it like this, it will only have only one record because this combination of two columns is a primary key in this table. Now let us see what happens if we try to insert a record which has same product ID and airport product name repeated. So in this previous insert statement, we already inserted one on airports, but let us see what happens if we try to insert one on airports again. So the insertion will fail because one and airports already exist because here product ID and product name. So the combination of these columns is acting as a primary key. So this combination one and airports already exist and we cannot insert any records with the same combination. But if we change the airports to airports pro, let's say, and if we try to insert this data, it will get inserted because there is no other record which says that one on AirPods Pro are present, right? So we have one on iPhone 15, one on MacBook Pro, one on AirPods, and one on AirPods Pro is going to be the new data or new row for this column. So this is how composite primary key can be used in tables. And now let us look at the not null constraint. So not null is also a constraint that will ensure that a column cannot contain null values. So this is essential for columns that must always have a value. Let's say that we have the same table, products table, which has product ID, which is a primary key, and there is a column product name, and we want to apply non-null constraint on this column. So we just need to mention not null in the DDL so that this column will have not null constraint applied on it. Let me try to recreate this table, and I'll copy these insert statements. I'll insert some data. So product ID is 1, 2, and 3. And for the product name here, I'll make it null. And if I try to insert product ID 1, it succeeded, and for product ID 2, it succeeded. And when I try to run this product ID 3, it fails because null value in a column product name. So it violates the not null constraint. So it will not let us make the product name null. In a product table, generally or sensibly, if we think about it, we always need a product name. So without a product name, it doesn't make sense to have any other data in the products table. So we don't want null values in the product name. And if we apply this non-null constraint, the product name will always be present in this products table. If someone tries to insert a null value for product name, it will fail, giving an error that it violates the not null constraint. So this is the use of the not null constraint. And there is one more constraint, that is unique constraint. So what is unique constraint? So this constraint ensures that all values in a column or a set of columns are unique. So unlike the primary key, it allows null values unless combined with a not null constraint. So the unique constraint is similar to the primary key, but it will also allow the null values. So it is not a primary key, but it will allow null values. So in this previous scenario, when the product ID is a primary key, and if we try to insert a null value into this product ID column, see product ID is primary key in the definition, and here we are trying to insert a null value. So it will fail because it violates the not null constraint. And we have not mentioned not null constraint for this product ID. Even though with the primary key, it's a combination of not null unique constraint, not null plus unique constraint. So the primary key is combination of not null and unique constraint. And let's look at the unique constraint. So I'll try to recreate this table again, and I will have product name as instead of not null, I will have unique. So I'll create this again. I created this table, and let us insert some data there. So I have product ID as 1. Let's say product ID is 2 here, product ID is 3, and our constraint on product name is unique constraint. So in the unique constraint, if we try to enter null value, it will allow. So let us have this, and let us have one more statement for product ID 4, and let's try to insert this iPhone 15 again. So let's try to run this insert statements. So I'm inserting the product ID 1, so it ran well, and for product ID 2 again it went well, and for product ID 3, so I am providing null value for product name. So if even if I enter a null value, it has executed successfully. And for the product ID 4, I am entering iPhone 15 as the product, which is already present as product ID 1, and the constraint on this column is unique, so it should not have any repeating values of the product name. Let me try to check what happens. So it fails because iPhone 15 already exists, and let me try to make this null. So it has executed this because null is not equal to null in SQL. So if two column values are null, they are not equal in SQL. So basically uniqueness check will ensure that the column where the uniqueness constraint is applied will have only unique values except the null values. So it will accept nulls and it will accept only unique records in that column. In this case, it is product name. So if we just quickly run the select, it says the product name has iPhone 15 and MacBook Pro and it has two null values. So it can have any null values if the constraint applied is only unique constraint. Now let's talk about another constraint called check constraint. So check constraint actually defines a condition that must be met for the values in a column. So it allows you to enforce specific business rules or data validation when you are inserting data in a table. So let's consider the same example. So in this example, we have product ID, which has primary key constraint here, unique constraint on product name. And let's say for the price column, I wanted to add a check constraint, and the check should ensure that the price is always greater than 0. So let me try to create this table again. And now I would like to insert some data into this table, and I'm inserting product IDs 1, 2, 3, and 4 and product values iPhone 15, MacBook Pro, AirPods, AirPods Pro. Okay, the fourth column is price. So this column is going to be the price. So our constraint says that price should be always greater than 0, which is logical here. And I would like to insert some product which is priced at minus 10, and I would like to insert something which is priced at 0. And I have already created these. Okay, I created the table with check constraint, and I am inserting the record 1, so which is successfully inserted, and the record 2 is also successfully inserted, and record 3, so which has the negative value for the price. It says that the new row for relation violates check constraint products price check. So this constraint products price check is failed because it has minus 10 as the value for price, and the constraint on this table is to check if the price is greater than 0. If it is not greater than 0, it will not insert that record into this table. Now even if you try to insert the data with the price equal to 0, it should fail because only if it is greater than 0 that should be allowed. So it has failed even for the 0 price. Now let's say if we make it price greater than or equal to 0 and recreate this, and if you run this now, it will allow because 0 is allowed in this condition. And let's say I'll run this again to check the data. See, the price is this. So even when we tried to insert this negative price, it did not insert because negative price doesn't have any meaning. So this is why the constraints are very important in SQL when dealing with data, and this will ensure that the quality of data that we are inserting into a table is good. And the next constraint that we will be talking about is going to be the default constraint. So default constraint is also very important. The default constraint provides a default value for a column when no value is specified during an insert. So let's say that I'm recreating this table again, and for the created date I am making this a default constraint, and the default value is going to be the current date. So and I'll recreate the table with a default constraint on the created at date column. So basically if you think, the created at column will store the data of when we created this particular record in a table. So we don't need to provide any value actually. So when we are inserting, the time when we are inserting should be picked up by the system automatically and should be inserted in this column. So when we apply this default constraint on this column, So when we are running the insert command into this table, the time will be picked up and that particular time will be automatically added to this column. So let us try to run this. I have this column which says date here. I'm just removing that date, and we don't need this -10 as well. I will insert the data for 1, 2 and 3. So I have run the insert command successfully. Now if I check the table, so you can see that the date is automatically inserted as today's date, which is 16th March. So you see here on the top right that the date today is 16 March. So this is where the default constraint help us. And the next type of constraint is the foreign key constraint. So basically a foreign key is a column or a set of columns in a database table that refers to the primary key of another table. Let's consider a scenario where we have a categories table which contains the category ID and category name. And if we look at our existing table products, here instead of category, I replaced it with category ID and it is an integer. And for this, we are referring this category ID to the categories table and the category ID column, which is this one. So this is a foreign key, meaning this is a column in a database table. So which is going to be this table, a column in this table, which refers to the primary key in the other table. So here category key is going to be the primary key. So this foreign key is used to basically create a reference between two tables. In this case, category ID is being referred in the category ID in the categories table. So it enforces the referential integrity, meaning the value in the foreign key column, which is the category ID column in the products table, must have a match in this categories table. Let's say if we have a number 1 here in the category ID, you should have that number 1 present in the categories table as well. So let's look at this with an example. So in order to create this table with a foreign key, we need to have this categories table present already. So if we drop this table products and if we create this table, right? So let's say that we don't have this categories table. Let me drop it if it is there. Okay, it doesn't exist. And I am trying to create this products table and it has a references to this categories. So in this case, category ID is a foreign key. So if I try to create this table products, it says that relation categories does not exist, meaning the categories table doesn't exist. So we need to have this categories table already present for us to use this foreign key in this products table. So for that, I'll create this categories table. So we have created the categories table and currently it's empty. So it says that it has the category ID, which is PK primary key, and it has category name. And now I would like to create my products table. So I created the products table, and if I look at the data, so it products table also doesn't have anything and it have the category id and category id will be referred to this table categories. Now I want to insert the data into my products table. So currently, as you know, the categories table is empty and I am trying to insert some data into the products table. This products table has product id as 1 and here the category id, which is the last column, is also 1. So if I try to insert this data into the products table, it fails because it says the foreign key, which is the category id equal to 1, is not present in the categories table because our categories table this is empty. So we have not yet inserted any data into this categories table. So as there is no data, when we try to insert this one, this references this foreign key will try to go and look for this number 1 in the category id column of the categories table. As the number 1 is not present, it is not inserting the data into the products table as well. Now if we go and insert some data into the categories table, let's say I am inserting category 1 as electronics, category 2 as computers, and category 3 as audio. Now I have inserted some data into the categories table and it has category id 1 2 1 3 present. So now I'll go on insert some data into the products table. Now I'm inserting the category id 1. So it is successful, and if I look at the products table now, So I got the category ID 1. And the same way I'm going to do with category ID 2 and 3 as well. So the data is successfully inserted. If you see, we have category ID 1, 2, and 3. Now I am going to insert the data for category ID 4. And in the categories table, we only have the IDs 1, 2, and 3. Now if we run this, it will fail obviously like earlier. So this is how the foreign key works. So basically the foreign key is used to maintain the referential integrity between two tables, and whenever you are inserting some data into the products table with a foreign key enabled on this category ID, and whatever the category ID that you are inserting in the products table should be present in the categories table as well. So if there is no match, then the data will not be inserted in the products table. And this is about foreign key constraint in SQL. We have created all the constraints when we are creating this table. But what if the table is already created and there is lot of data in the table already, and then we want to create some constraint on top of this table? So for that, you can just alter the table. So let's say that I wanted to add a constraint on this column, which is the stock quantity column, and I wanted to ensure that the stock quantity is always greater than 0. For that, I can just write alter table. So the command is going to be alter table. We are going to alter this table, and we will add constraint, and we'll name this constraint as check stock. And this is going to be a check constraint, and I want to ensure that the stock quantity is always greater than or equal to 0. So if I just run this statement, and this constraint is applied on that table on the column, and when I try to insert data, and if I insert any other value like -10 for the stock value, it will say that it failed because check stock is not satisfied. But if I just remove this stock quantity to be 10 and insert this data, it says that okay, there is some other constraint, AirPods Pro already exists. Let me make it AirPods Pro 2. So it will successfully insert this data. So this is how, using the alter table command, we can add a new constraint on the existing table. And now let's say that you want to drop this constraint, so which is check stock, and you just need to do alter table, and instead of add constraint, you provide the drop constraint and remove everything else, and you run this statement, you should be able to drop the constraint. And if you try to insert some other record on this table which has negative value of price, it should allow because we dropped the constraint check stock. So now if you run this select star from products, you can see that there is a negative -10 stock quantity present. And now let's assume a scenario that here the stock quantity you have already -10. Now if you apply some constraint on this stock quantity now, so let's say that I have altered table products and I am adding a constraint. My constraint is going to be check stock. So this is going to be the constraint, and I want to check the stock quantity greater than or equal to 0. So I want to add this constraint to this table. So if I try to add this constraint, so some data is not already violating the rule. This -10 on stock quantity is already violating the rule. Now when I try to run this statement or add this constraint, it will fail because it is already violated by some row. And now if you try to insert the data for AirPods Pro 4, which is -10, so it will execute because the previous statement, which is altering the table products and adding a constraint for stock check, has already failed. So for adding any constraint, you have to ensure that the data that is already present in the table should not violate the constraint or the rule that you are newly applying to that column. So these are basically the different types of constraint, and this is all about constraints in SQL. Now let us also talk about how do we manage these constraints in a larger databases or in a real-time databases in companies where we are dealing with a lot of data. That's where the identity column comes into picture. So identity column. So what do we mean by identity column? Let's say you are having a constraint which is the primary key constraint on product ID. And today you have inserted some 100 records. So the product ID you entered is from 1 to 100. And tomorrow when you are inserting some new records, you have to remember the older number 100 so that you don't repeat any of the existing product IDs, and all the new IDs will be entered from the coming inserts. So you always need to manually keep track of these primary keys that are already present in the table. So to overcome that and to avoid manually managing the unique IDs, which can be sometimes prone to errors, especially in large data sets, the identity columns come into play. So an identity column automatically generates unique values for each new row. When you are inserting some data into this products table, you need not manually mention any product ID. So an identity column will automatically generate unique values for each new row, simplifying the insertion and ensuring uniqueness. So let's create a products table with an identity column for product ID. So the DDL is going to be very similar. Okay, I already have the DDL here. So I say that I am dropping the table products and I am recreating the products. The only change here is that you have this keywords generated always as identity. So if you mention this when you are inserting the data, you need not mention the product ID here. So you need not manage the product ID. So let us see how this product ID is managed if you are not providing the product ID manually. So let me just drop and recreate this table, and now I am inserting these three records. So if I select the data from this, so it says that the product ID is 1213, which is automatically handled. Now if I insert three other records, iPhone 16, MacBook Pro 2 and AirPods Pro, I am inserting three more records which are different, and this is successful. And if I check the data, so it has inserted new product IDs, so which is 456, which are not conflicting with the existing product IDs. So the identity column will help us generate the primary keys easily. So the database will basically assign a unique and sequential ID to each row, ensuring no duplicates and simplifying the data loading. And now it's very important to understand the impact of deleting data and inserting again on an identity column. Because let's say when we are inserting data for product ID 1 and 2, and if we insert some other records, so we should know whether this product IDs 1 and 2 will be coming again, or will they be not coming again at any time on this product ID column in the life cycle of this table. So let's see deleting data from the table. I want to delete the data where product ID equal to 2. And if I check this products table now, so product ID 1, 3, 4, 5, 6 are there, and the product ID 2 is missing. And now when I insert some new data, right, I'm inserting some new data which is AirPods Pro. When I insert and select this data again, it has not inserted product ID 2. Instead, it has inserted a new product ID which is product ID 7 for the data that I have entered. So whenever you delete data from a table, the product ID will not be impacted. So any product ID is gone, that is gone, or any identity column row is gone, that will not be regenerated again, even if you delete this complete table. So I'll just run delete from products, and I'll see there is no data. And if I try to run this insert statement now and check the data again, it will insert from product ID 8, it will not insert from product ID 1. So that is how deleting data works in identity columns. This behavior is important because it ensures that you don't accidentally reuse primary key values, which could lead to data integrity issues and all those things. Now let's see what happens when we truncate the table, right? Let's say I'm executing this truncate table products. So truncate is very similar to delete, and so if you truncate the table, it will not accept any where clauses. Instead, it will delete the complete data in the table. And now if I look at the products table, so there is no data. And if I run this insert into products now after truncating the table, even now it's going to insert the primary key from the next coming number, which is going to be 9. So this is going to be the impact of deleting and truncating tables which has the constraints and identity columns applied to the table.